Voyager's transmitting alarming information back to Earth. Voyager 1, NASA's most distant spacecraft, continues to explore uncharted regions of the cosmos nearly 50 years after its launch. Scientists are puzzled by the unsettling data this renowned space probe is sending back. Join us as we discuss the peculiar information Voyager has been transmitting during its interstellar exploration journey. Scientists have been engrossed in cutting-edge knowledge about the universe's history since the Big Bang, which motivated the launch of the Voyager missions. Voyager 1 and Voyager 2, among other space missions, were part of this effort. Voyager 2 was actually the first spacecraft to launch, departing from NASA's Kennedy Space Center on August 21, 1977. Voyager 1 was launched 2 weeks later, on September 5 of the same year. Despite their similar design, each probe weighing approximately 720 pounds, akin to a small car, they were launched during a period of unique outer planet alignments that allowed a slingshot effect to propel them from one planet to another. They had to travel at different speeds and on different trajectories. On December 15, 1977, Voyager 1 was able to overtake its twin, Voyager 2, and since then, it has been our primary source for data about various space phenomena. The first spacecraft to perform this was Voyager 1 when it began its Jovian imaging project in 1978. At that time, it was about 265 million kilometers from Earth and sent a vast number of images back to us. Voyager 1 completed an impressive 108-hour stint starting in January 1979, capturing 3,750 photographs of Jupiter's rotation to create a time-lapse film showing 10 hours of the planet's spin. It passed through the Jovian moon system in February 1979 and, a month later, discovered Jupiter's faint rings. Voyager 1 also made a notable discovery by identifying new moons, which were named Thebe and Métis. Voyager 1 was then prepared for its flyby of Saturn to avoid potential collisions with Titan, one of Saturn's moons. During its orbit of Saturn, Voyager 1 discovered 4 additional moons: Mimas, Enceladus, Tethys, and Dione. After completing the Saturn mission, NASA decided to halt the planetary exploration phase of the Voyager missions and send Voyager 1 and Voyager 2 out of our solar system at a speed of 325 million miles per year. In January 1990, the Voyager interstellar mission began. On February 14, 1990, Voyager 1, then 6 billion kilometers from the Sun, took what are now iconic images known as the pale blue dot photos. It captured a total of 60 images, bringing the spacecraft's total image count to 670. Although Mercury and Mars were not visible in these images due to various reasons, the spacecraft's cameras were later shut off to conserve energy and memory before its journey into interstellar space. In addition to the interstellar probes Voyager 1 and Voyager 2, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Prior to Voyager 1 surpassing Pioneer 10 on February 17, 1998, Pioneer 10 held the record for the farthest spacecraft. Voyager 1 continued its journey for another 14 years before finally reaching interstellar space on August 25, 2012. However, NASA did not publicly announce this milestone until 2013. As of November 2018, both Voyager 1 and Voyager 2 have officially left the solar system. While Voyager 2 crossed the heliopause and entered the interstellar medium, Voyager 1 is believed to be 14.5 billion miles from Earth. It continues to provide crucial data that no other spacecraft has been able to gather since it ventured into the unexplored regions beyond our solar system. Despite its longevity and generally good health over its 45-year mission, recent anomalies in Voyager 1's performance have raised concerns. Voyager 1 is currently transmitting mysterious signals back to Earth, suggesting that its status may be more precarious than previously thought. Although scientists had pre-programmed Voyager to enter safe mode or sound an alarm if it became lost in space, it has not yet done so. Its antenna, which transmits data back to Earth, seems to be functioning well, but the data it is sending is unusual. The spacecraft is operating and executing commands from Earth, as well as collecting and transmitting scientific data, but readouts from its articulation and control system do not accurately reflect the current situation. Each spacecraft headed into interstellar space, including Voyager 1 and 2, carries a 12-inch gold-plated disc containing audio and video messages as a backup in case an extraterrestrial civilization encounters it. The disc includes 35 Earth sounds, 115 images, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary-General Kurt Waldheim, recorded in 55 different languages. Despite speculation, there is no evidence suggesting that the spacecraft is under alien control. Voyager's ability to function depends heavily on its attitude and articulation control systems, which keep its antenna aimed at Earth for effective data transmission. Engineers monitoring the situation believe the systems are operating correctly, which adds to the mystery. None of the safety features designed to protect the spacecraft have been activated. According to Susan Dodd, project manager for Voyager 1, encountering such mysteries is expected at this stage of the mission. The spacecraft is about 45 years old, which exceeds its expected lifespan, and the engineering team faces significant challenges in resolving these issues. The vast distance between Earth and Voyager 1, approximately 14.5 billion miles, introduces many complications. A rescue operation is almost impossible given current technological and logistical constraints. Voyager 1 is beyond the reach of any spacecraft or repair mission we could feasibly dispatch. Its remarkable journey has taken it to the outermost regions of our solar system and into interstellar space, where it continues to travel farther away from us. Messages sent from Earth take nearly 21 hours to reach Voyager 1, and any command or instruction sent requires a full 42 hours to be received and acknowledged, creating a significant challenge for real-time problem-solving and troubleshooting. Once Voyager 1 receives a command, the response or data it sends back to Earth also takes 21 hours to return. This means that two-way communication between Earth and the spacecraft takes about 2 days. This delay complicates quick fixes or iterative troubleshooting, making it essential for the engineering team to meticulously plan and execute each command. The engineering team must carefully prepare each command to address known issues without causing additional problems, given the extended time required to verify the command's effects. This substantial communication delay limits the team's opportunities to interact with the spacecraft, requiring each command to be precise and leaving little room for errors. This necessitates rigorous testing and validation of commands on Earth before transmission to Voyager 1. Moreover, the spacecraft's technology, dating back to the 1970s, is now considered outdated by modern standards, adding complexity to the problem-solving process. The harsh conditions of space, cosmic radiation, extreme temperatures, and micrometeoroids have contributed to the wear and tear on Voyager 1's systems over its 45-year mission, making maintenance and repair even more challenging. Despite these obstacles, the engineering team remains committed to resolving the issues. They are exploring various hypotheses about the potential causes of the anomalies and testing possible solutions through simulations on Earth. This meticulous and cautious approach is critical, as any incorrect command could worsen the situation or lead to a loss of communication with the spacecraft. The team is also leveraging the redundancy built into Voyager 1 systems. Designed with backup systems to enhance resilience, the engineering team can switch to these backups if a particular component fails. In summary, while diagnosing and resolving issues with Voyager 1 is daunting, the team is applying their expertise and the spacecraft's inherent resilience to tackle the challenges. Their careful approach is crucial in managing the extensive communication delays and the complexities of working with a spacecraft that is both extremely remote and considerably aged. Despite the difficulties, their efforts aim to continue Voyager 1's legacy of exploration and scientific discovery far beyond its original mission parameters. The malfunctions may be attributed to cosmic rays impacting the spacecraft's delicate electronics, as these high-energy particles from distant supernovae or other cosmic events travel through space at nearly the speed of light and can penetrate the spacecraft's exterior, affecting its internal systems. The longer the spacecraft remains in space, the greater the likelihood that cosmic rays will impact its systems. These cosmic rays are high-energy particles that can interfere with Voyager 1's electronic systems, causing anomalies in its data transmission. The prolonged exposure to such particles, combined with the spacecraft's age and harsh space environment, further exacerbates the risk of malfunctions. As Voyager 1 continues its journey into the vast expanse of interstellar space, the engineering team remains vigilant, analyzing data and running simulations to understand and address these challenges. Each day brings new insights and possibilities, as they strive to ensure that Voyager 1's mission of exploration and discovery endures despite the odds. The spacecraft's onboard systems were meticulously designed to withstand the challenges of space travel, but prolonged exposure to the harsh environment has inevitably taken its toll. Cosmic rays, which are high-energy particles emitted from distant cosmic events, such as supernovae, can penetrate the spacecraft's exterior and disrupt its internal electronics. These particles travel at nearly the speed of light, making them difficult to shield against. As Voyager 1 continues its voyage through interstellar space, the potential for these cosmic rays to cause further issues with its systems increases. The age of Voyager 1 also presents significant challenges. Launched in 1977, the technology on board is now considered outdated compared to modern standards. Despite this, the spacecraft's design included numerous redundancies to enhance its durability and operational longevity. The engineering team at NASA is continuously working to address any problems that arise, using their extensive knowledge and the spacecraft's built-in backup systems. Given the vast distance between Earth and Voyager 1, communication delays are a major hurdle. Messages sent from Earth take approximately 21 hours to reach the spacecraft, and commands sent to Voyager 1 require a full 42 hours to be received and acted upon. This delay complicates real-time troubleshooting and problem-solving. Engineers must carefully plan and execute each command, anticipating various outcomes and ensuring that each instruction is precise to avoid exacerbating any issues. Voyager 1's mission has provided invaluable data about the outer planets and beyond, but maintaining the spacecraft in its current state requires constant vigilance. The engineering team remains committed to understanding the anomalies and working through the challenges posed by the spacecraft's remote location and advanced age. Their goal is to ensure that Voyager 1 continues to contribute to our knowledge of the cosmos for as long as possible, despite the many obstacles it faces. The spacecraft's journey is a testament to human ingenuity and perseverance. As it travels further into the unknown, its continued operation and data transmission offer a unique and lasting legacy of exploration. The insights gained from Voyager 1's mission extend far beyond its original objectives, providing valuable information about the boundaries of our solar system and the nature of interstellar space.